Okay, we're going to do 10.5 today, area of parallelograms, triangles, and trapezoids. So we're going to start with parallelograms. So let's just talk about the formulas real quick. Some of them you might remember from earlier school years. Some of them you might not, or maybe you didn't go over them. Parallelograms. So first of all, just remember that parallelogram. I always say that it's a rectangle caught in a windstorm. Has similar characteristics to the rectangle as mentioned before. So it has opposite sides are congruent and opposite angles are congruent. There's two acute angles and two obtuse angles. So that's your parallelogram. Your parallelogram has a base and a height, not a length and a width. A length and a width is on a rectangle. It has a base and a height. For a parallelogram, you can't measure something that's on a slant. So your height will always be drawn in. It may be inside of the figure and it'll kind of drop down from an angle and have your 90 degree, or it might be on the outside. And if you notice what I just built there with those dotted lines is I built that rectangle. So I need a 90 degree angle in order to have my height. Remember these words. Base meets height at a 90 degree angle. So find your 90 degree angle and you will always find your base and your height. So area of a parallelogram is equal to base times height, okay? Area of a triangle, there are lots of different kinds of triangles. So you will always look for the base and the height of a triangle. Now, think about a triangle. So if I have a parallelogram like this, and if I take that parallelogram and I cut it in half, I have a triangle. So the formula for a triangle is the similar formula to a parallelogram, only you're gonna divide it in half because a triangle is half of a parallelogram. So the area of a triangle is equal to base times height divided by 2. That's one way to write it. Or you can write it like this, base times height divided by 2, whichever one you want to remember. So this is your triangle formula. So this is for the triangle. This is covering one of these. Your trapezoid, remember your trapezoid can take different forms too. It can look like this, bad one, or it could look like this. Because the only thing that trapezoid has to have is one pair of parallel sides. Remember how we make parallel sides with the arrows? Only one pair of parallel sides. It doesn't have to have any sides congruent. So for a trapezoid, sometimes the height is already there. Remember, you'll know the height because it meets the base at 90 degrees. So this is height and this is base. But look at, there's also a 90 degree there. So which base is base? Well, there's two bases in a trapezoid. It doesn't matter which one is base 1 and which one is base 2. You just need to know you have two bases. So again, for this one, you would have your height drawn in because you can't measure height on a slant. And then you have your base and your base. And this is your height. So your formula for a trapezoid is base 1 plus base 2. Got to add those first. Then you're going to multiply it by the height. Then you're going to divide it by 2. So that's your formula. It's not that hard to remember. And it doesn't matter which one is base 1 and which one is base 2 because the commutative property tells you it doesn't matter how you add these. What matters is that you do add them first before you multiply it by the height and divide it by 2. So be careful when you're using a calculator. When you're using a calculator, either use the proper symbols, the parentheses, to tell your calculator, I want you to add these before you multiply by height and divide it by 2. Remember, order of operations matters in this. Okay, so those are your 3 formulas that you need to get into your head. Notice they're both all three of them are using base and height. If you think about your pictures, they all make sense. Parallelogram's easiest, which is base times height. Triangle is a parallelogram, half of it, which is why your base times height divided by 2. And your trapezoid is base 1 plus base 2 times the height divided by 2. So let's practice. Starting with your parallelogram. There you go. How do you know this is the height? Because it's straight up and down and it's meeting the base. So your area is just going to be 3 times 3, which is 9. Make sure you understand that area is in squared units, not in linear. It's in squared units. So you would write 9 meters squared. Please make sure that the little 2, the square sign, goes next to the unit and not next to the 9. Goes next to the unit. So 9 meters squared. So I would want you in your homework to write area is equal to 9 meters squared. And you can use your calculators on these. This time the height is drawn inside, so it's 6 and 2/10 times 4 and 3/10, 26 and 66/100 inches squared. And again, you can write squared inches or you could just write inches squared like that. So that's a parallelogram. So this one, 12 centimeters squared. This one, 1 in 95/100 feet squared. So notice this one. How do you know its height? Creates a 90-degree angle with the base. How do you know its height? Creates a 90-degree angle with the base. So now we have our triangle. Base times height divided by 2. Why? Because it's half of a parallelogram or half of a rectangle or half of a square. So whatever you do, you're going to have to multiply the two numbers together and divide it by 2. So 3 times 4 divided by 2, and you're going to get 6 meters squared. Now, notice they're multiplying it by a half. That's the same thing as dividing it by 2. So if I was going to write this out, I would rather that you do area is equal to base times height divided by 2. It doesn't matter which one's the base and the height. Commutative property tells you it doesn't matter how you multiply these. There you go. 6 meters squared. This one, same thing. How do I know it's the base and the height? There's that 90-degree angle. It connects base and height. So it doesn't matter which one. Multiply those two together, divide it by 2, and you end up with 12 and 48/100 feet squared. And there we go again. This one is 15 times 12 inches squared. 3 and 6/10 times 5 and 2/10 centimeters squared. So there's your triangle. So that's your parallelogram, base times height. Your triangle, base times height divided by 2. Let's go to our trapezoid. So here you have your trapezoid. Now, if I had a measurement here and here, so let's say that this was, well, that's 7.5. So let's say that this is like, that's 6. Hard because it doesn't make sense. So this is 5 3/4, and this is 5 3/4. So let's say they had all these measurements on there. You're not going to use them, so it's important that you understand which ones you use. You use the 2 parallel lines. Those are the ones that are the bases. It doesn't matter which one's base 1 and base 2. How do I know this is a height? It created the 90-degree angle with the bases. So I'm going to do 5 1/4 plus 7.5, and you can turn those into decimals, times the height, 6, divided by 2. So I'm going to do 5 1/4 plus 7.5, times 6 divided by 2. Just like that. You can put it all in your calculator in one full swoop or into your phone. Once you do that, you're going to get your answer of, don't worry about all this cross-canceling, 38 1/4. So let's go back because that's a mess. So once you do this on your calculator, you're going to see that you get 38 1/4 meters squared. The nice part about it is, remember, you can stop, pause, and rewind if you need to, if I'm going too fast. So base 1 plus base 2 times the height divided by 2. There you go. Yep, got it. Here we go. And you don't need a calculator for this one. You can do this one in your head. Base plus base times the height divided by 2. So 6 plus 2 is 8. 8 times 5 is 40. And 40 divided by 2, 20 feet squared. And remember, don't forget your units, because every time you forget your units on an assessment, that's like a half a point off. So make sure you really focus in. The area is in squared units. Oh, a wall that needs to be painted is 16 feet wide and 9 feet tall. So we have a wall. Best wall ever. It's 16 feet wide and 9 feet tall. There's a doorway, that's exciting, that's 8 by 3. That's not really a good picture, is it? And then there's a window, just one window, that's 6 by 5.5. What is the area to be painted? Well, I'm pretty sure we're not going to paint the door and the window. So I want you to think about it. If I only want to paint the wall, not the door and the window, what are you going to do to figure out this problem? Right. You're going to find the area of the door, and you're going to find the area of the window, and you're going to find the area of the entire wall. And you're going to subtract the door and the window away from the area of the total wall. So let's look at this. You find the area of the wall. You found the area of the door. We found the area of the window. So you just take 144, which is the total wall, and subtract away the door and the window to find out how much square feet you're going to have to paint. So 87 square feet. This time we get to plant a garden. A garden needs to be covered with fresh soil. The garden is 12 feet wide and 15 feet long. I personally always like to draw a picture because it allows me to be creative with my drawing with my mouse, which is not always good. We know that, but that's okay. You guys don't mind. Oof. So it's 12, something's wrong. So it's 12 feet wide and 15 feet long. It's a good garden. A rectangular concrete path runs through the middle of the garden, and it's 3 feet by 15 feet. Well, anyways. Find the area of the garden which needs to be covered with fresh soil. Let's assume that you're not going to put soil on the concrete path. So think about how you're going to solve this problem. So if it's 3 feet wide and 15 feet long, so it's like this is a concrete path. You're going to put soil on that, and it's 3 by 15. So find the area of the total garden, 15 by 12, and then find the area of the concrete path, and then subtract the two of them. So 12 times 15 is going to be 180 feet squared, and then you're going to take away the 15 times 3, which is 45. Subtract those two from each other to get your total of 135 feet squared. That's it. So hopefully you're successful and you get to know those formulas well. It's easier just to get them into your brain and understand them. Good luck.